Hello everyone, welcome to today's class. Let's continue with our topic of limits and let's solve limits by one more method known as rationalization. Okay. So rationalization, I think everyone remembers, change the sign of denominator, and usually it was done when square roots were involved. So the hint is whenever you see square roots in question, usually it will be of rationalization for limits. Let's look at the question. Limit x tends to 0, root 2 plus x minus root 2 upon x. Now again I'll show you that by direct substitution, if I put x as 0, this is root 2 minus root 2 upon 0. So that is 0 by 0. Same problem. We cannot use this. So we can see square roots in numerator. Now forget that idea that rationalization only has to be done in denominator. No. If you have any expression in the numerator that has square root, you'll do rationalization. If you have any expression in the denominator that has square root, you'll do rationalization. If both numerator and denominator has square roots in it, you'll do rationalization of numerator and rationalization of denominator also. Okay. Let's do rationalization. So limit x tends to 0, root 2 plus x minus root 2 upon x. In order to rationalize, the factor that is multiplied is change the sign here. So root 2 plus x plus root 2 upon root 2 plus x plus root 2. The numerator will have the identity of a plus b, a minus b. A is root 2 plus x, b is root 2, a minus b, a plus b. So that's a square minus b square. So 2 plus x basically minus 2 upon x, and this is, don't multiply the denominator because there is no benefit here. You are not getting any sensible expression here. 2 cancels, you'll get x by x, and x by x will also cancel. So remember, I'm cancelling it one go, but it's not like I have cancelled x with x and then 2 with 2. 2 and 2 cancels, so it remains x by x, which is 1. So it is 1 upon root 2 plus x plus root 2. And the moment numerator and denominator something gets cancelled, we know after that direct substitution works. No? It's a good thing. The moment we see numerator and denominator cancels, yes, now limit x tends to 0 will work. So let's put 0. So 1 upon root 2 plus root 2, that is 1 upon 2 root 2. Yes, that's the limit of this function. Let's see next. Limit x tends to 0, x upon square root of a plus x minus square root of a minus x. Again, doesn't matter whether you have numbers or some arbitrary constants, answer will come in terms of a. Why is that a problem? So again, I'm not going to check any direct substitution. I know this will not work. 0 by 0, you can check it yourself. So rationalize. So in order to do the rationalization, x upon square root of a plus x minus square root of a minus x, limit x tends to 0. Change the sign, this one, that's it, and multiply. So square root of a plus x plus square root of a minus x, same with the denominator. Now this time denominator has the property of a minus b, a plus b, so that is a square minus b square. So x, don't do anything with the numerator, x square root of a plus x plus square root of a minus x. Just put them in multiplication only, okay, don't solve it. The denominator will become a square minus b square, so a square is a plus x minus b square is again a minus x, but remember to put them in a bracket. Still limit is x tends to 0. So limit x tends to 0. If you open this bracket, what do you get? A cancels and x plus x, so 2x you will get. So x upon 2x, a plus x plus a minus x, and x also cancels. The moment numerator denominator cancels, we have to do direct substitution. So 1 by 2 root a plus root a, because 0 0 we have to put na. So root a plus root a is 2 root a, 1 by 2 into 2 root a. That's root a is the answer. Okay, so simple concept, but it's just that the problem in the exam that you'll face is now the question will never come with a heading that use this method or use that method. Remember from the last class there was one question of square root, but there we didn't do the rationalization. You can check it under the heading of direct substitution. There direct substitution was working. So before doing the rationalization, make sure that it is 0 by 0 format and the direct substitution is failing, then only do the rationalization. Okay, all right, let's do the same idea one more time. Limit x tends to 0, square root of a square plus x square minus square root of a square minus x square upon, this time, x square. Again 0 by 0 by direct substitution. Okay. So rationalize. Okay. Let's copy first the question, then multiply by changing this sign. So a square plus x square plus a square minus x square. Numerator again a plus b a minus b, so a square plus x square minus a square minus x square in a bracket, and denominator keep as it is. X square was there na? So x square bracket a square x square plus a square minus x square. Limit is still x tends to 0, not h. Sorry. So if you open this bracket, a square will cancel, and x square it will become plus x square, so 2x square. So again it becomes 2x square upon x square, and denominator is same. Okay. So x square cancels. The moment numerator denominator cancels something, we know the direct substitution will now work. So 2 upon root a square plus x is 0 na, so 0, so this becomes a square, square root of a square is a plus a, so 2 upon 2a, that's 1 by a as the answer. Okay. All right. Next, limit x tends to 4. Okay. X square minus 16 upon square root of x square plus 9. Minus 5 is outside the square root. Remember, x square plus 9 is inside the square root. Okay. So we already know that if we do the direct substitution, for 4 square is 16 minus 16 is 0, and 4 square is 16 plus 9, 25, square root of 25 is also 5 minus 5, again 0 by 0. So we know we have to do the rationalization here. Square root is a norm, so change which sign? This sign. Okay. Plus 5 root of x square plus 9 plus 5. So limit x tends to 4. A square minus b square, it is looking like this or not? First of all, a square minus b square. So let's solve that. Maybe it will help us, maybe not. Let's see. X plus 4, x minus 4. Okay, and denominator becomes a square minus b square. So a square is x square plus 9 whole square in square root. So it becomes x square plus 9 minus b square is 5 square, that is 25. Oh, it was coming x square minus 16 only. So we don't need as such right now, but in some other question they can do that, like that they give, instead of this x square minus 16, what they can give you is some quadratic function where you have to do the factorization as well. Okay, so there is no restriction in the question that it has to be from the factorization only or rationalization. They can merge the concept also. I was expecting a merger, but it was not there. Okay. X square plus 9 plus 5. Okay, so this becomes minus 16. Okay, so that means this whole denominator cancels with the numerator, and then we have to do the direct substitution. So I put x as 4, so square root of 16 plus 9 plus 5, that's 5 plus 5, that's 10 as the answer. Okay, so far what we have done is rationalize numerator, rationalize denominator, everything we have rationalized. Let's look at one more question. Limit x tends to 4, 3 minus square root of 5 plus x upon 1 minus square root of 5 minus x. Okay, this time if you see, how does this question differ from the others? This time you have square root in both numerator and denominator. What did I told you for rationalization? That if you get square root in both numerator and denominator, you will have to rationalize both of them. Okay, so before even doing that, let's check whether direct substitution is working or not, which it will not. The numerator becomes 3 minus 5 plus 4, 9 square root of 3 is 3 upon 5 minus 4, 1 minus 1, it is coming 0 by 0. So yes, it is failing. So now what we have to do is we have to rationalize both numerator and denominator. How can we do that simultaneously? We will not do that. We'll do one at a time. How do we do that? 3, write down numerator like this. Okay, and then write down denominator after some space, 1 upon 1 minus square root of 5 minus x. Do the rationalization of this first. So in order to rationalize, multiply it by 3 plus, change this sign, so 3 plus 5 plus 5 plus, my bad, 5 plus x, 3 plus square root of 5 plus x. Okay, here also you do rationalization, 1 minus, so change it to the plus, 5 minus x, 1 plus square root of 5 minus x. Okay, let's solve. Numerator again a square minus b square, so 9 minus 5 plus x. No, that will also become minus now once you open the bracket. Okay, upon 3 plus square root of 5 plus x in the square root into this one, numerator as it is, denominator is 1 minus 5 plus x. So this becomes 4 minus x upon 3 plus square root of 5 plus x. This becomes 1 plus square root of 5 minus x upon there's something wrong. They should have come same. 5 plus x question is correct. Yeah. Minus plus minus, negative minus 5 minus x, that's okay. Negative a square minus b square minus 5 plus x, it is coming 4 plus, it's coming 4 minus. Why? Let's solve, let's see. It will come 1 minus 5 plus x. Oh, it is coming minus 4, huh? It's okay. No, I'm overthinking. 4 minus x, 3 plus square root of 5 plus x, copy. 1 plus square root of 5 minus x. This becomes minus 4 plus x. So same thing, na? This is 4 minus x, that's minus 4 plus x, difference in sign. So if we take negative common here, it will become minus 4 plus x, the sign will change, or I can do the same here also. Effectively they become same, so we can cancel them, and the moment numerator and denominator something gets cancelled, we can do direct substitution. Limit x tends to 4, limit x tends to 4. Every step you are solving, na, you have to write limit x tends to 4. But that's from subjective point of view. If you are doing an objective question, just solve this. Even take less steps. Okay? So minus of, this is coming limit x tends to 4 minus of 1 plus square root of 5 minus x upon 3 plus square root of 5 plus x. Now we have to put x as 4. Let's do the direct substitution. So negative of 1 plus 5 minus 4 is 1 upon 3 plus 5 plus 4 9, 3 plus 9 square root is 3 plus 3 6. So minus 2 by 6 or minus 1 by 3. That's the answer. Okay. All right. Done. Okay. That pretty much summarizes your rationalization. Okay. That what you have to do if both numerator and denominator gets a square root. Usually you'll get 1 square root, but if you get 2, be prepared to do rationalization 2 times. Okay. That's it. That was rationalization. Let's look at the next method, that is using standard limit. Now this is, I'll say, the only formula for this chapter, because it is technically not the only formula. 1 2 3, like 3-4 formulas are there, very less formulas are there, ideas are more here. So the formula is limit x tends to a. It is applicable to this format only, x raised to power n, a raised to power n upon x minus a. This value you should directly know, this is n into a raised to power n minus 1. Okay. When you have to use this, use for high value, fractional value of n. If you get n as some fraction or some higher value, like x raised to power 5 or x raised minus 2 raised to power 5, something like that, or x raised to power 7 minus 2 raised to power 7, something like this. The moment you see that those kinds of expression, you will know that this is standard limit. You have to use this formula. Effectively, the remaining formulas that I was talking about, they are very easy to learn, but this one is slightly typical because it looks like this. Let's see. The questions again are very straightforward because it's a formula based limit. Okay, no concept. First 2 that we solved was based on the algebraic identities, factorizations, and your rationalization. So look at the question. First one, limit x tends to 2, x raised to power 10 minus 1024 upon x minus 2. Okay. Now look at the, first of all, look at the value of power. So 10. I told you that higher power is usually hint of this. Okay. So by comparing that, first of all, let's rewrite this. Okay. And again, direct substitution will not work, because if you calculate 2 raised to power 10, that's 1024. So numerator will also be 0, denominator will also be 0. So it doesn't work. So let's rewrite this as x raised to power 10 minus 2 raised to power 10 upon x minus 2. By comparing, first of all, you can see for yourself that your n is 10, your a is 2. So use the formula. X tends to 2. Formula is n, so 10, then a, that is 2 raised to power n minus 1, yeah, means 10 minus 1. So that is 10 into 2 raised to power 9. 2 raised to power 9 is 512. So 5120 is the answer. Okay. The format has to be matched exactly. Remember that. Next, limit x tends to still 2. This time x raised to power 10 minus 1024. But denominator is x raised to power 5 minus 32. Now what will you do? You could have used this formula, but the denominator has to be x minus a. Means if only it was having, first of all, you have already solved na, this one. So you know if only x denominator was x minus 2, you could have easily solved this. So if you need something, generate that. For the upcoming topics, this will be the key idea. You need something, you generate it. How do you generate that? Same thing, limit x tends to 2, x raised to power 10 minus 2 raised to power 10 upon x minus 2 I have put on my own. Okay. So if I am dividing numerator with x minus 2, I have to divide denominator also with x minus 2. So x raised to power 5, 32 is also 2 raised to power 5 upon x minus 2. So I have divided both numerator and denominator with x minus 2. Nothing wrong. So now you can see this is a standard formula or standard limit. This is also a standard limit. You can solve this. This is 10 into 2 raised to power 10 minus 1, 9 upon this is 5 into 2 raised to power 5 minus 1, that's 4. So that is 2 into 2 raised to power 5, that's 2 raised to power 6, that's 32, 64 is the answer. Okay. You need something, generate that. Okay. All right. Next, limit x tends to, this time let's take 9, x raised to power 3 by 2 minus 27 upon x minus 9. It is looking like standard limit, but it has to become limit x tends to 9, x raised to power 3 by 2 minus, then denominator, this is a, na? A is 9. So this has to be 9 raised to power 3 by 2. Now you calculate separately whether 9 raised to power 3 by 2 is 27 or not. So 9 raised to power 3 by 2 means 3 square raised to power 3 by 2. That is 3 raised to power 2 into 3 by 2. 2 cancel, 3 raised to power 3, that is 27. So that's correct. I can write 27 as this. Okay. No need to learn it, no need to generate it. See for yourself. You can, first of all, why I'm doing this? Because I know this value is fraction, very abrupt value. So, and the denominator is looking like x minus a. So pretty much standard limit can be applied if only it was 9 raised to power 3 by 2, which it is, upon x minus 9. I think now it's pretty easy. N, that is 3 by 2 into a, that is 9 raised to power 3 by 2 minus 1. So 3 by 2 into 9 raised to power 1 by 2. 1 by 2 means square root. Square root of 9 is 3. So 9 by 2. That's the answer. Okay. Done. Next, limit. Let's take arbitrary constant x tends to a. X root x minus a root a upon x minus a. Now you might think, yes, there is a square root involved. We can rationalize. You can try. Maybe it will work, maybe it will not. You'll have to see for yourself. Okay. Right now what I can see easily here, what is square root of x? Means power 1 by 2. So basically x root x is x into x raised to power 1 by 2. It becomes x raised to power 3 by 2. Look at the expression now. X raised to power, it becomes limit x tends to a. Okay. X raised to power 3 by 2 minus a raised to power 3 by 2 upon x minus a. Again, standard limit is working. N is 3 by 2. Okay. So 3 by 2 a raised to power 3 by 2 minus 1. So 3 by 2 into a raised to power 1 by 2. That's 3 root a by 2. Okay. All right. Next, limit x tends to a. X raised to power m minus a raised to power m upon x raised to power n minus a raised to power n. Okay. In order to work for this standard limit, what do we need? The denominator as x minus a. It's not present. So what did I told you? If you need something, generate that. X raised to power m minus a raised to power n divided by x minus a. Numerator is divided, so we have to divide the denominator also. Okay. In order to keep the expression same, one standard limit in numerator, one standard limit in denominator. So that is m a raised to power m minus 1 denominator. This one is formula itself, n into a raised to power n minus 1. So m by n, and do the property of exponents in division, they will get subtracted, so it will become m minus n. Okay. M minus 1 minus n plus 1, so 1 will cancel effectively. Okay. All right, one more, limit x tends to 2, x minus 2 upon cube root of x minus cube root of 2. Now if you look at this expression, you will have to see that if only this was the numerator and this was the denominator, because the formula is x raised to power n minus a raised to power n. Na? So the power of n should be in the numerator. Okay. So what will we do? What do you need here? You need x minus 2 now. So what you can do is you can divide both numerator and denominator with x minus 2. So limit x tends to 2, x minus 2 divided by x minus 2, numerator is also divided, denominator is also divided, and I will repeat, change this cube root of x. What is cube root of x? Power 1 by 3. So x raised to power 1 by 3 minus 2 raised to power 1 by 3 upon x minus 2. This one cancels, and this one is our standard limit. That's 1 upon 1 by 3 into 2 raised to power 1 by 3 minus 1. Okay. Let's take this here. Let's solve this further. This becomes 3 upon 2 raised to power minus 2 by 3. This becomes 3 into 2 raised to power 2 by 3. You can leave your answer there. All right. Now one variation. So far we just learned how to apply the standard limit. Now look at the variation. Limit x tends to 0, 1 minus x raised to power n minus 1 upon x. If you see this, first of all, it's not even looking like a standard limit. Okay, because the expression has x minus something, x raised to power n, a raised to power n upon x minus a. Denominator is, there is no such thing as x minus a. Okay. Now what do we do? Let's see. Okay, this is an important variation, so I'm putting a star. First of all, let's see direct substitution. So 0, so 1 minus 1 upon 0, 0 by 0, so yes, of course it won't work, otherwise why would be doing this as a separate question. Now what can we do? See, let's, for the time being, let's say I want to force standard limit on it. So the standard limit looks like this: the variable raised to power n minus some constant raised to power n upon x minus a. Okay, the name of the variable can be anything. It's not a condition that it always has to be x. It can be y, t, m, n, doesn't matter. Okay, so right now I'll consider this as my new variable. Okay, so I'm considering 1 minus x is some y. Okay, so in that scenario, the numerator will look like y raised to power n. 1 can be written as 1 raised to power n, because 1 raised to power anything is 1. Now let's see denominator. Denominator is x. If I'm using 1 minus x is y, what is the value of x? X is 1 minus y. Okay, so it will become 1 minus y. If I take negative common, I have to rearrange, means I have to change the order. So it will become, instead of 1 minus y, it will become y minus 1. And now you can see the question has become a question of standard limit just by using this conversion. Of course, it was not easy to see, but it is actually getting manipulated. This is the first problem. Second problem with this question is the question still says limit x tends to 0. Here y is working, there is no x. So somehow I have to write limit y tends to something. Now I'm not sure whether I should write 0, 1 or 2 something, whether this expression will change or not, whether I should write y tends to 0 same as here or not. Let's see. For that also we have this to help. Okay, so I'm solving it here. It's known as changing the limit. Okay, whenever you do the substitution, you have to change the limit. Now right now the question is saying x is tending to 0, means x is, you can I do call it tending to 0, but you can understand as x is 0. Okay, you have used 1 minus x as y. If x is 0, what is y? 1 minus 0, so that is 1. So I can say when x is tending to 0, then y is tending to 1. I'll repeat, x is tending to 0 means x is getting close to 0, or let's say simply x is equal to 0. If x is 0 and I use this expression 1 minus x equal to y, so 1 minus 0, if I put x as 0, 1 minus 0 equal to y is coming 1. So when x is 0, y is 1. So I can say when x is tending to 0, y is tending to 1. So this limit was actually y tends to 1. So there are two problems involved. First, changing the variable. Second, changing the limit. Remember that changing limit is very important. Don't think that you can still put x0 here, or you can replace y0 directly. Okay. Now this becomes, if you just forget about this negative, this becomes a standard limit. The formula is again same as negative can be written in numerator, so minus n into 1 raised to power n minus 1. 1 raised to power anything is 1, so this is minus n as the answer. Last part was very simple, but to convert, that was a good idea. Okay. Let's see one more question to get you comfortable with changing the limit. Limit x tends to a. Okay. X plus 2 raised to power 5 by 3 minus a plus 2 raised to power 5 by 3 upon x minus a. Okay. All right. Direct substitution will not work. So what we do? You can see this time at least it is looking like standard form, but the problem is here you have x plus 2 and here you have a plus 2. So basically you can literally do this without changing limit or anything, because this is very simple as long as you follow the basic idea. I'll change the formula in terms of capital X raised to power n minus capital A raised to power n upon capital X minus capital A. Just replace the alphabet with capitals, because otherwise it will create confusion. Now if you compare it with this, the numerator, if you just compare numerator is x plus x is capital X is x plus 2 and capital A is a plus 2, but the denominators are not matching. So yes, we can rearrange this. What I'll do is I'll do plus 2 here, okay, so that it has become x plus 2. And if I'm doing plus 2 here, I'll not change the question, I'll rewrite it, otherwise when you read it through notes it will create confusion. Okay. Limit x tends to a x plus 2 power 5 by 3 minus a plus 2 raised to power 5 by 3 upon x minus a. So what I'm doing, I'm saying I'm adding 2. If I am adding 2, I have to subtract 2, and if I take negative common from these two, it becomes a plus 2. And now you can see this and this, they are matching with this these expressions. Capital X is x plus 2, capital A is a plus 2. So as per the formula, this will become this will become n into a raised to power n minus 1. Okay, so that means it will become n is 5 by 3. Capital A is actually a plus 2 raised to power 5 by 3 minus 1. So 5 by 3 a plus 2 raised to power 2 by 3. Yes, weird answer, but yeah, this is it. Okay. If you want, you can do the same question in term by replacing x plus 2 is equal to y and a plus 2 as some b also, and then you have to go through the changing limit process and everything, but I think this one is pretty much straightforward, so use this directly. Okay, all right. Next, limit x tends to 1 x raised to power 4 minus 1 upon x minus 1 is limit, this one is simple and let's not do that. Limit x tends to 2, this one is okay, x raised to power n minus 2 raised to power n upon x minus 2 is 80. Find n. Okay, this time you have to find n accordingly. So how will we do that? This is standard limit, so use the formula. That will be n into 2 raised to power n minus 1, that's your 80. And the problem is, this is a equation in which the variable is linear as well as in the power. There's no way to solve it properly. There is one way, but I'll recommend you to do the check. Either you check the options by putting the values, okay, or if you are solving it properly, so just do like that. Put n equal to 1, it will not work. N equal to 2, 2 into still not work. 80 is a big value, so 1 2 will not work. 3, it is coming 3 into 2 raised to power, still very small. 4, 4 into 2 raised to power 3, 8, 432, no. 5, so 5 into 2 raised to power 4, 16 into 5, that's 80. Yeah, so 5 will work, so n is 5. Use it and trial for these. Don't try to solve it in a proper manner. It can be done slightly with a proper manner, but again that effectively is lengthy, and this one is very quick. Just put 1 2 3 4, because usually you will have smaller values to deal with, or if the options are available, just use 4 options now. Whichever satisfy this equation will be your answer. That covers your standard limit. Okay, let's see one more. Limits at infinity means this time x will be tending to infinity. Let me give you the idea first. The idea is when x is tending to infinity, I can say 1 by x. Now denominator. Now if x is in the denominator, so 1 by x means it is equal to like 1 by infinity. And infinity is a very large number. So if you divide 1 by a very large number, it will come 0.000000 something like that. Very large, no? So basically I can say this 1 by, if x tends to infinity, 1 by x tends to 0. This is the only idea that we'll use here. Okay. So let's see the questions. How do we use that? Limit x tends to infinity. Ax square plus bx plus c upon dx square plus ex plus f. Okay. So how do you calculate that? You generate expressions of 1 by x, 1 by x. So basically whatever is the highest power in the numerator, whatever is the highest power in the denominator, divided by that. Okay, x square is the highest, so divide numerator by x square, divide denominator by x square. So mathematically the question remains same. So if you do that, so it will be a plus b by x plus c by x square upon d plus e by x plus f by x square. You know 1 by x is, if x is tending to infinity, 1 by x is tending to 0, or directly we can say 1 by x is 0. So limit x tends to infinity. This is tending to 0, this is tending to 0, this is tending to 0, this is also tending to 0. So what is left in the numerator? A, and denominator d. That's your answer. So try to generate expressions of 1 by x, 1 by x. That's the only way to solve these kinds of limits. Okay. Let's see the question now. Limit x tends to infinity. 5x minus 6 upon square root of 4x square plus 9. Okay. Now numerator, you have highest power as x. If I'm dividing numerator by x, I have to divide denominator by x also. So that becomes 5 minus 6 by x. If you take x inside the square root, it will become x square. Okay, like root x square is x na. So if you want to take x inside the square root, it becomes x square. Try to think reverse. So this division with x means division with x square inside the square root. So it inside the square root, it will be 4 by 4 plus 9 by x square. Okay, divide this expression by x square inside the square root. Now same thing, whatever is 1 by x is tending to 0, tending to 0. So remove it. So it is, answer is coming 5 by root 4. That's 5 by 2. That's the answer. Okay. Limit x tends to infinity. You have 3x square minus 1 plus 2x square minus 1 upon 4x plus 3. Okay. The moment you see, again I am saying still the same thing, the moment you see infinity, you try to generate 1 by x, 1 by x. So dividing denominator by x, dividing numerator by x, this x will become x square inside this square root, inside this square root also. So this will become square root 3 minus 1 by x square. This becomes root of 2 minus 1 by x square upon 4 plus 3 by x. Same idea, 0, 0, 0. Okay. So root 3 plus root 2 by 4. Okay. so far in all the questions you see there was numerator and denominator. That's why you were able to divide numerator and denominator both. Okay, look at this question now. X tends to infinity, square root of x plus c minus square root of x. There is no denominator. If you divide numerator, there is no denominator to divide x with. So your method of this generating 1 by x is not working here. Then what can we do? What we'll do is the same thing that we used to do. The moment you see square root, what do? Rationalize, na? Rationalize. So let's rationalize. Square root of x plus c plus square root of x, square root of x plus c plus square root of x. So numerator becomes x plus c minus x, and denominator is x plus c plus root x, and limit is x tends to infinity. X cancels, so this becomes limit x tends to infinity, root x, c multiplication, root x plus c plus root x. Again, same idea. If I divide by x, I think it will become x square in the denominator. We can do that, or use this square root. This divide numerator and denominator by this root x only. Okay, because root x is here also. So this time instead of dividing with x, I'm dividing directly with root x. So numerator becomes only c, denominator becomes plus 1 will be here, and this will be square root of x plus c by x, which is effectively, I can rewrite this as 1 plus c by x. Okay, so again use the idea, 0. So what do we get? C by 1 plus 1, 2. So c by 2 is the answer. Okay, so each term, remember, if multiple terms are there, each term will be divided by root x, first one or as well as the second one. Okay, all right. Let's mix it a little bit. Limit n tends to infinity, 1 plus 2 plus 3 plus up to n upon n square. You have to calculate this. Now this expression 1 plus 2 plus 3 plus up to n, this is a standard formula in AP, that is summation n also, and it is called, one second, it is called summation n, and the formula is n into n plus 1 by 2. Okay, this was in AP. Okay, if you have studied it, it's good. If you have not, then when we'll do the AP, you can go through that. Okay, we'll be discussing this separately anyway. And upon n square. Okay, so this question has used concept of AP, or you can use sum of n terms of AP formula is also there. You can use that also, but effectively this is very much standard. 1 plus 2 plus 3 up to n is n into n plus 1 by 2. Okay, so by 2 I'll write here. Okay, now you see numerator, do you see denominator? N is tending to infinity. In order to solve that, what we can do is, first of all, cancel this n and n. So limit n tends to infinity, n plus 1 upon 2n, split the denominator, limit n tends to infinity. This will become 1 by 2 plus 1 by 2n, and this is tending to 0. So okay, n is tending to infinity, so 1 by 2n tends to 0. So this is 1 by 2 only. That's the answer. Okay. All right. Let's mix it with factorial. Limit n tends to infinity, n factorial upon n plus 1 factorial minus n factorial. Now factorial, we have mixed it with limits. This is what we can do. Okay, and of course, don't think that trigonometry cannot come here. Of course, that is a very specific topic, trigonometric limit. So trigo will also come. Right now, it's factorial. So n factorial numerator, it's okay. Let it be. Denominator n plus 1 factorial. You know n plus 1 factorial can be broken down as n plus 1 into 1 less factorial. Okay, because n factorial is n factorial into n minus 1, like this. Basically, your idea is like 5 factorial can be written as 5 into 4 factorial, 1 less factorial. So n plus 1 factorial is n in plus 1 into n factorial minus n factorial. Numerator is also n factorial. So effectively, limit n tends to infinity, limit n tends to infinity. You take n factorial common in the denominator. Here. It will get outside and you will be left with n plus 1 minus 1. Okay. N factorial cancels. 1 plus 1 cancels. So the question effectively will look like this. Limit n tends to infinity, 1 upon n. And if n is tending to infinity, this is 0. So 0 is the answer of this question. So usually whenever you see these kinds of the question in the exam, you see factorial, then you see limit, and you see that there are two concepts directly involved. The moment you see this, you think this is very complicated, we have to leave this. But no, you can see this was very easy. One single property of factorial, the question becomes so simple. Okay. All right, that's it. That is pretty much regarding how to solve limit n tends to infinity type questions. Okay, this lecture is over. We'll start with the remaining types of limits in the next class. Still, I think it will take one more lecture for this. Okay, all right, good day everyone. See you in the next class. Bye.